Alright class, I want us to have some extra review of going over how to find real zeros. So the first thing I need to do is list all possible rational zeros. I'm going to do that by minding my P's and Q's. Remember that all of my factors of my constant are my P's, and all of my factors of my leading coefficient are my Q's. So the possible factors of P are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. The possible factors of Q, making life really convenient, is just 1. So my possible rational zeros are P over Q, which is going to be plus or minus 1, because 1 over 1 is 1, plus or minus 2, because 2 over 1 is 2, plus or minus 3, because 3 over 1 is 3, and plus or minus 6, because 6 over 1 is 6. Now I'm going to find all rational zeros using the remainder theorem. What is the remainder theorem? Well, remember, the remainder theorem says if I have f of c, where c is a possible zero, and it equals 0, then c is a 0. So I need to find a p over q such that f of p over q is 0. So let's go ahead and get started. The best place to start is at the beginning. So f of 1, that would be 1 cubed plus 1 squared minus 5 times 1 minus 6. Well, that equals negative 9, so that's not going to be it. F of negative 1, that equals negative 1 cubed plus negative 1 squared minus 5 times negative 1 minus 6, which is negative 1 plus 1 plus 6 minus 6. Plus 5, minus 6, which is going to give us a negative 1. So 1 and negative 1 are not zeros. Let's go ahead and check f of 2. Well, f of 2 gives us 8 plus 4 minus 10 minus 6, which is a negative 4. But f of negative 2 might be our answer. Negative 2 cubed plus negative 2 squared plus 10 minus 6. That gives me negative 8 plus 4 plus 10 minus 6, which is 0. Hooray! So I know that x minus negative c, because it has to be like x minus c is a factor, if c is a 0, that x minus negative 2, which is x plus 2, is a factor of my polynomial. So now I need to use synthetic division in order to figure out, if I remove this degree 1 polynomial, what degree 2 polynomial I have left. So let's go ahead and clear us some space. So much space. So I already have, we'll switch to a nicer color too. I just found that f of negative 2 is 0. Hooray! So negative 2 is a factor. I can use synthetic division to determine what my remaining polynomial would be. So I'm going to pull down this 1. Negative 2 times 1 is negative 2. 1 and negative 2 is negative 1. Negative 2 times negative 1 is a positive 2. Negative 5 and 2 is a negative 3. Negative 2 times negative 3 is 6, and the remainder is 0, just like we found, right? So I'm left with this trinomial. So I know x plus 2 is a factor, because that's x minus a negative 2. I'm left with x squared minus x minus 3. Now I need to factor this quadratic in order to determine my remaining zeros. So the first thing I think is, okay, what are the factors of AC that add up to B? Well, there are no factors of negative 3 that add up to negative 1. So we're going to have to use the quadratic formula. And we're going to start using the quadratic formula by labeling our A, B, C's. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 3 all over 2 times 1. So x equals 1 plus or minus the square root of 1 plus 12, which is 13, over 2. So my factors are going to be f of x equals x plus 2 times x minus 1 plus the square root of negative 13 over 2 times x minus 1 minus the square root of 13 over negative 2. So in this case, I have 1 rational and 2 irrational factors. But remember, irrational numbers are still real. Let's take a look at another example. If I have x to the fourth minus 9x squared minus 4x plus 12, the first thing I want to do is find all possible rational zeros. That's always going to be our first step. So I have 12. The factors of 12 are my p's, and the factors of 1 are my q's. So p is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Oh my gosh, that's a lot of factors. But I think we'll be okay because my q is just 1. So my possible rational factors, my p's and q's, those are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Who knew 12 could have so many factors? So let's go ahead and start by using the remainder theorem to find PQs such that f of PQ is 0, then x minus p over q is a factor. So let's start with 1. F of 1 equals 1 to the fourth minus 9 times 1 squared minus 4 times 1 plus 12. So f of 1 equals 1 minus 9 minus 4 plus 12. 1 minus 9 is negative 8. Negative 8 minus 4 is negative 12 plus 12 is 0. Hooray! This is a factor. So I need to go ahead and use synthetic division to determine what my remaining polynomial is. As of right now, I have f of x equals x minus 1, because 1 is a factor. So I'm going to take my coefficients. I've got 1, a 0 placeholder for my cube, negative 9, negative 4, 12. I pulled on this 1. 1 times 1 is 1. 0 and 1 is 1. 1 times 1 is 1. Negative 9 and 1 is negative 8. 1 times negative 8 is negative 8. Negative 4, negative 8 is negative 12. 1 times negative 12 is negative 12. Negative 12 and 12 is 0, as we expected. So I'm left with x cubed, because I had a degree 4, now it's a degree 3, x cubed plus x squared minus 8x minus 12. Now here's the problem. I don't know how to factor a cubic. I know how to factor a quadratic. We've got the quadratic formula, but I don't know how to factor a cubic. So we need to keep factoring. So I'm going to clear us a little bit of space so we can factor x cubed plus x minus 8x minus 12. Now notice my last coefficient, my constant, is still the same, so it still has the same possible zeros. So now I'm looking at x cubed, oh no, x cubed plus x squared minus 8x minus 12. Okay, this is my new little like f sub 1 of x, we could call it. So f sub 1 of x, I'm going to plug in some values into x cubed plus x squared minus 8x minus 12 in order to hopefully find a factor. So f of 1 is 1 plus 1 minus 8 minus 12, which is negative 18, not cool. F of negative 1 gives me negative 1, cubed is negative 1, plus 1, plus 8 minus 12, well, I still get a negative 4. Again, not good. F of 2 gives me 2 cubed, which is 8, plus 2 squared, which is 4. Minus 16 minus 12, well, that gives me a negative 16, but f of negative 2 gives me negative 8 plus 4 minus 16 minus 12, which is 0. Woohoo! So I know that that x plus 2 is a factor of this polynomial, so we're going to use synthetic division. So I've got a negative 2 out here, and my constants of 1, 1, negative 8, and negative 12. I pull down a 1. 1 times a 1 is, 1 times a negative 2 is negative 2. 1 and negative 2 is negative 1. Negative 2 and negative 1 is a positive 2. 2 and negative 8 is negative 6. Negative 2 times negative 2 is a positive 12. So my remainder is 0. So I'm left with this, which is x squared minus x minus 6. So now I have f of x equals x minus 1, because we can't forget our original factor, x plus 2, and x squared minus x minus 6. Now, I need to factor this quadratic right here. So I'm going to go ahead and say, what are the factors of AC that add up to B? This is like step 4. I need to factor x squared minus x minus 6. So what are the factors of AC, which is 1 times negative 6, which is negative 6, that add up to B, which is negative 1? Well, that's going to be negative 3 times 2, because negative 3 plus 2 is negative 1. So this is going to factor to x minus 3 times x plus 2. So my original polynomial fully factored is f of x equals x minus 1, x plus 2, x plus 2, x minus 3. So you can see I have fully factored f of x equals x minus 1, x plus 2 squared, so it has a multiplicity of 2, and x minus 3. So my zeros, if I was to set each of these equal to 0, so I've got x minus 1 equals 0, so I get x equals 1, x plus 2 equals 0, so x equals 2, and x minus 3 equals 0, so x equals 3. So my zeros are 1 and 3 and negative 2, but negative 2 has a multiplicity. Remember, a multiplicity, because it occurs twice, a multiplicity of 2. Remember, when something has an even multiplicity, if I was graphing it, it just touches the x-axis. It doesn't cross the x-axis.